Hi students, how are you all? Welcome to the fifth part of the chapter Calorimetry. Yeah, we already discussed 4 sessions, and all those 4 sessions we discussed about heat capacity, specific heat capacity, specific latent heat, and then few numericals based on specific heat capacity and specific latent heat. And this is the 5th session. The link of those 4 sessions are there in the description box. You must check that. And in this 5th part, we will discuss about mixing 2 materials. We'll mix 2 liquids of different temperature, and we will see what is the final temperature. Not understood? Don't worry. See, we are taking 2 vessels. Okay, this is vessel 1, vessel 2. Fine, 2 vessels are there. Here I am taking water. Fine, water at say 50 degrees Celsius. Here I am taking another liquid. Say this is also water. Okay, but temperature is 70 degrees Celsius. Okay, here is water 50 degrees Celsius, and this is also water 70 degrees Celsius. Fine. Now we will mix both the liquids. Means waters we are mixing. Okay. So when you are mixing these 2 liquids, then you are getting another liquid. Or say when you are mixing water. So you are getting the water. What is its temperature? I mean, what is the final temperature when you are mixing 2 liquids? The first liquid, that is water, 50 degrees Celsius. Second liquid, 70 degrees Celsius. When you are mixing them, what is the final temperature of that mixture? Understood? Now this final temperature depends on 2 things. Number 1, mass of both the liquids. Okay, mass of both the liquids plus specific heat capacity of both the liquids. Understood? So mass of both the liquids and specific heat capacity of both the liquids, that depends on. Okay, so let's start the numericals. Let us start with the easy numerical. You can see it's displaying on your screen. The first numerical, it's very easy. Like specific heat capacity of a substance A. A is a substance whose specific heat capacity is 3.8 joule per gram per Kelvin, and another substance B whose specific heat capacity is 0.4 joule per gram per Kelvin. Which substance is a good conductor of heat? Understood? Which substance is a good conductor of heat means through which substance the heat can travel faster. Okay, the heat can travel faster through which object? That object is the good conductor here. Now for that we have to see one rule is there. You have to see whose specific heat capacity is less. The substance with less specific heat capacity, that substance will get hot faster. Okay, means जितना कम specific heat capacity है, उतना जल्दी वो गर्म होगा और उतना जल्दी वो ठंडा होगा. That is the simple rule. Understood? Okay, the substance with less specific heat will get heated faster. Not only that, that substance will get cool faster. Okay, very simple rule. I told you, जितना कम specific heat capacity उतना वो जल्दी गर्म होगा. Understood? और उतना जल्दी ठंडा भी होगा. Okay, so here the specific heat capacity of a substance A, the first substance A is 3.8, B is 0.4. So first is 3.8 and this is 0.4. So who is the which substance is the good conductor of it? Which substance is the good conductor of it? Yes, B is the good conductor of it, because B's specific capacity is less than A. So B is the best good conductor of heat. Since its specific capacity is less, so it will get heated faster and it will get cool faster. Okay, so that's B is good conductor of heat, because B's specific heat capacity is less than the specific capacity of A. Understood? Let's see the next question. In next question, we are going to mix up two liquids. Okay, we'll mix up two liquids. I told you that. Let me take out this question. You can see the question is displaying on your screen. Next question. A mass of 50 gram of certain metal. You are taking a metal. Okay, let us write it first. We are taking a metal. This is the metal. Okay, whose mass is 50 gram. 50 gram. At 150 degrees Celsius, temperature is 150 degrees Celsius. Okay, now is immersed in 100 gram of water. Here water is there, mass equal to 100 gram of water. Yes, 100 gram whose temperature is 11 degrees Celsius. 11 degrees Celsius. The final temperature is 20 degrees Celsius. Understood? So actually say this is the vessel in which we are taking water. This is water. Okay. Now in this water you are going to immerse. Say this is the metal. This is the metal. Now I am going to immerse this metal in water. Now this is the metal. Okay. What is the temperature of the metal? 150 degrees Celsius. What is the temperature of water? 11 degrees Celsius. So when they comes in touch, okay, when you have immersed the metal in water, you will observe that the temperature of water and metal both are changed. Okay, so what is the final temperature here? What is the final temperature of this whole system? Okay, that we have to find. No, that is given in the question. That final temperature is 20 degrees Celsius. The final temperature is 20 degrees Celsius. Okay, so when you are mixing them, we are getting the final temperature 20 degrees Celsius. Understood? Now, out of this metal and water, which is of higher temperature? The metal is of higher temperature. That means metal will give heat. Fine. Now, metal and water, which is of less temperature? Water. That means water will take heat. Understood? Metal will give heat because the temperature of metal is higher than water. So that's why metal will give heat. And water will take heat because the temperature of water is less than metal. Understood? Let's see. And one more thing, the amount of heat given by the metal and the amount of heat taken by water should be equal here. Understood? I repeat. You understood that metal is giving heat because metal is of higher temperature, 150 degrees Celsius, and the temperature of water is less. Okay, so water will take temperature, means this metal will give heat, water will take heat. Okay, metal will give heat and water will take heat, and the amount of heat given by metal and the amount of heat taken by water will be same. Okay, let's write it. Amount of heat given by metal should be equal to amount of heat taken by water. Understood? Very simple formula. Who is giving heat? Metal is giving heat, because temperature of metal is higher than water. So metal is giving heat. Okay. Who is taking heat? Water is taking heat. Why? Because water's temperature is less than metal. Fine. So what is the amount of heat given by metal? Very simple formula. Ms T2 minus T1. Okay. Ms T2 minus T1. How to apply this formula? See. Amount of heat given by metal. Ms T2 minus T1. M means mass, 50 gram. 50 gram into specific heat capacity of the metal. We have to find it. Yes. Specific capacity into T2 minus T1. T2 minus T1 means metal is giving heat. So you have to write the temperature of the metal first. Understood? Who is giving heat? Metal. So you have to write the temperature of that metal. What is the temperature of that metal? 150. So 150 minus, what is the final temperature? Final temperature is 20. So this is 20 equal to, now amount of heat taken by water. How much heat the water is taking? Same formula, Ms T2 minus T1. So Ms, what is the mass of water? 100 gram. 100. S, specific heat capacity of water. What is the specific capacity of water? That is given in the question. 4.2 joule per gram per Kelvin. So that is 4.2. Now T2 minus T1. Who is taking heat? Water is taking heat. In that case, the final temperature will be written at first. Final temperature and then temperature of water. Okay. What is the final temperature? 20 minus temperature of water. What is the temperature of water? 11. So we'll write 11. Understood? So what I told you, who is giving heat? That material's temperature will write first. See. Okay. Who is taking heat? Water is taking heat. So water's temperature will be written at last. Water temperature. Understood? And rest of the part, this final temperature I am writing. I repeat, who is giving heat? Material is giving heat. So material's temperature will be written at first. Now who is taking heat? Water is taking heat. Water's temperature will be written at last. Water temperature. Understood? Now we have to solve the equation to get the value of missing. What is missing here? The specific heat capacity of the material or the metal is missing. So we have to find the specific capacity. So let us calculate it. So 50 into S, 130, that is 100 into 4.2 into 9. Fine. So S equal to, this 50 into 130 will go down. 50 into 130, 100 into 4.2 into 9. Okay. Now let us calculate it. 52 is Fine. So by 2 we can cut 65 ja. Now 4.2 into 9. Okay, 4.2 into 9 by 65. You have to calculate this. 4.2 into 9 divided by 65. Whatever we are getting, that is the answer. Answer means the specific heat capacity of this metal. Okay, and what is the unit of specific capacity? Joule per gram per Kelvin. Okay, joule per gram per Kelvin. Understood? This is the answer. Let us move to our next sum. Next question. 200 gram of hot water at 80 degrees Celsius is added to 300 gram of cold water. Okay, here both the things are water. Like in the first sum, what we did? We had a metal and water. Water and metal we were mixing. But here we are mixing water. Both the materials are water. So let us write this. First is water. This is also water. Now 200 gram of hot water at 80 degrees Celsius. Its mass is 200 gram. Temperature is 80 degrees Celsius. The next water is 300 gram of cold water. 300 gram whose temperature is 10 degrees Celsius. Fine. Now we are adding it. Okay. What is the final temperature? That final temperature we have to find. In the first numerical, the final temperature was given. But here the final temperature is not given. We need to find it. So, first tell me, because now you got the concept, who is going to give the heat? Yes, the liquid with higher temperature. Which liquid is higher temperature? This liquid is with higher temperature, so it will give heat. Okay, who will be taking heat? Obviously this will be taking heat. Why? Because its temperature is less. So let's write it. Amount of heat given by this water, amount of heat taken by that water. I am not writing it, but you have to write amount of heat given equal to amount of heat taken. I am directly writing the equation. You must write that. Okay. So what is the amount of heat given? Amount of heat given is 200 into specific capacity. Specific capacity of water is 4200 joule per kg Kelvin. 4200. Okay, into. Now, who is giving heat? This water is giving heat. What is this temperature? 80. So 80 will be written at first. 80 minus final temperature. T is the final temperature. So we are writing here equal to. This water is taking heat. Okay, taking heat means what is the mass? 300 gram. Gram we are not writing. 300 into what is the specific heat capacity? 4200. It's given in the question. 4200 into this water is taking heat. So the temperature of that water who is taking heat, that will be written at last. So we are writing here, that is 10. Okay, what should I write here? Yes, final temperature T. Any doubt? I told you in the previous sum that who is giving heat, that temperature will be written at first. Who is taking heat, the temperature of that material will be written at last. Understood? Now let us calculate it. But one problem here. The problem is, see, mass is given in gram. Okay, mass, both the masses were given in gram. But in specific heat capacity, specific heat capacity, it's mentioned kg. Okay, 4200 joule per kg Kelvin. Okay, 4200 joule per kg per Kelvin. That is given in kg. So gram has to be converted into kg. How to convert gram to kg? Divided by 1000. We have to apply it here. So divided by 1000. Divided by 1000. Understood? So gram to kg just by dividing by 1000. Okay. Now see, 4200 4200 is cancelled from both the sides. Understood? Actually, when two liquids are same, means two liquids means both the liquids you are mixing, the two liquids which are mixing, the liquids are same, then the specific heat capacity. If you do not write specific capacity, no problem, because ultimately you are going to cancel them like this, because here water, okay, water. So I am writing specific capacity of water, specific capacity of water. That's why both are cancelled. So when two liquids are of same type which you are going to mix, in that case the specific heat is not required to mention in the equation. Just write SS so that you can cut that, because ultimately finally you are going to cut them. So why to write the values? Okay. Now 1000 also cancelled. So 200 into this, that is 16,000 minus 300 into this. Okay, let us take all the T this side. Okay, now minus 200. Now here, minus 500 T will do this one 0 0 0 1900. Okay, now T equal to minus 19 38 degree. So 38 degree is the final temperature of above mixture. Okay, so when two liquids you are mixing, then the final temperature depends on, as I told you, final temperature depends on the mass and specific heat of both the liquids or both the materials. Okay, so in this way, by using this, you can find out the final temperature. Let's see the next question. Next sum. 45 gram of water at 50 degrees Celsius in a beaker is cooled when 50 gram of copper at 18 degrees Celsius is added to it. So here we are going to add water and copper. Let us write it. First of all, water and then copper. Water is 45 gram. Temperature is 50 degrees Celsius. Now copper. Copper is 50 gram, 18 degrees Celsius. 50 gram, 18 degrees Celsius. Fine. Water and copper. Adding. We have to calculate the final temperature. Okay. So the technique is same. Who is giving heat? Water is giving heat. Okay, water is giving heat. So let us write the water part first. What is that? Water is 45 into specific heat capacity of water. What is the specific capacity of water? That is given 4.2 joule per gram per Kelvin. So 4.2 into, who is giving heat? Water is giving heat. So the temperature of water will be written at first. What is the temperature of water? 50 degree, 50 minus final temperature T equal to, now who is taking heat? This copper is taking heat. So let us write the copper's part first. Then 50 into specific heat capacity of copper. What is given? 0.39. 0.39 into, who is taking it? Copper is taking it. So copper's temperature will be written at last. So what is the temperature of copper? 18 minus final temperature T. Any doubt on this? Fine. So the same technique, who is giving heat and who is taking heat? First of all, you have to identify that. Who is taking heat and who is giving heat? That you have to identify first, and after identification, the formula is the amount of heat given equal to amount of heat taken. So who is giving heat here? Water is giving heat. So amount of heat taken equal to amount of heat given. Okay, amount of heat given equal to amount of heat taken. Here the water is giving heat and copper is taking heat. Okay, so let's continue this calculation now. So 45 into 4.2 into 50 minus T equal to 50 into this. Now you know the calculation. First we have to multiply these two, then we have to remove the bracket. After removing the bracket, if you continue this calculation, we will get final temperature. Okay, so whenever you are mixing two liquids or any solid or liquid you are mixing, you will see that whose temperature is higher. The liquid or the material with higher temperature means that material will give heat. Okay, now another material whose temperature is less, that material will take heat. Okay, and formula is same, mass into specific heat capacity into T2 minus T1. Okay, out of T2 and T1, one is final temperature and other one, how to put that I already told you. So let's see another sum. 1 kg of water is contained in a 1.25 kilowatt kettle. Calculation the time taken for the temperature of water to rise from 25 degrees Celsius to its boiling point. This sum is little bit different. Here we are not going to mix like in the previous sums. We were adding either two liquids we added or one liquid and one solid we added. But here we are not going to add anything. This sum is little bit different. Here they have mentioned an electric kettle. Okay, electric kettle, like say this is the electric kettle, you know that, this, and here is a plug. Okay, we have to connect this kettle with electricity. Okay, and from that electricity it converts to heat, so it produces heat here. Understood? So this is the kettle, say this is the kettle. So from the electricity what it's getting, that electricity is converted into, yes, heat here. Okay, and by that heat it heat up the liquid it's containing. What is the liquid here? 1 kg of water is there in this kettle. Okay, 1 kg of water is there. Now, so 1 kg of water whose temperature is 25 degrees Celsius to 100 degrees Celsius, you are changing the temperature. The initial temperature of water was 25 degrees Celsius. Now you are increasing that temperature to 100 degrees Celsius. Yes, 100 degrees Celsius. So how much heat you have to give? Okay, how much heat you have to give? We have to give 1 kg into specific heat capacity of water. Is it given? Yes, it is given. 4.2 joule per gram per Kelvin. So, into 4.2 into the change in temperature 25 to 100, that is 100 minus 25. Okay, this is the amount of heat required for water. Okay, by this formula we are getting the amount of amount of heat the water is taking. Okay, now who is giving that heat? The kettle is giving that heat. Okay, here the power of the kettle is given. The power of the kettle is 1.25 kilowatt. Okay, 1.25 kW means 1.25 kilowatt. That is the power of that kettle. Now how much time is required? There is a very simple formula of that. Okay, how much heat a kettle gives? For that, just what you have to do, the power into time, the time for which this kettle is functioning with the electricity, means for how long you are functioning, you are running that kettle. Okay, say the power of the kettle is P into for how long you are running the kettle, say T is the time, T. So this is the amount of heat given by this kettle. Okay, what is the amount of heat you are taking from the kettle? Amount of heat you are taking from the kettle means the power of the kettle into the time for which you are running the kettle. Understood? What is the power of the kettle? That is given 1.25 kilowatt, but you need to change it. 1.25 kilowatt means 1.25 into 1000 watt. You have to convert it into 1000. So power 1.25 into, let us write it here, 1.25 into 1000 into time. Time is not given here. We have to find the time. Yes, time we have to find here, into time. Okay, this is the amount of heat the kettle is giving. Who is taking that heat? Water is taking that heat. Yes, water is taking that heat. That means these two things has to be equal. Okay, these two things has to be equal, because water is taking heat and kettle is giving heat. Amount of heat taking, amount of heat giving, both are equal. So that's why 4.2. Oh, one more thing. See the question. The specific heat capacity of water is given 4.2 joule per gram Kelvin. Okay, gram is mentioned, but the your specific capacity of this what is that called? Yeah, the mass of water is given in gram. Okay, mass of water is given in, no, it's kg. Mass of water is in kg, but specifically given in gram. So they are not matching. Mass is given in kg, that is mass is given in kg, and this is given in gram, joule per gram. So let us change it. 4.2 has to be changed. Okay, 4.2 joule per gram, 4.2 joule per gram Kelvin means we have to multiply this by 1000. Okay, just we have to multiply this by 1000. So 4.2 into 1000, we are getting 4200 joule per gram Kelvin. So we are getting here not 4.2, we'll write here 4200. Okay, 4200. That means if mass is in kg and that your specific capacity is in mass is in kg and specific capacity in gram, then you need to change that. You need to change that specific heat capacity from gram to kg you have to change. Okay, so that is what I am doing by just multiplying 1000. So 1000. Okay, so this way. Now, so what we are getting here? 4200 into 75, and that should be equal to this, because this is the amount of heat water is taking, and this is the amount of heat the kettle is giving. Okay, so what is the amount of heat? If you cancel this point 100, so 00 cancel, 1250 T. Okay, now T equal to fine. Now 0 cancelled by 5. Okay, 5 ja 5, 3 ja by 5. 84 into 3, 252 second. Okay, this time has to be in second and this power has to be in watt. Fine, the power has to be in watt and time is in second. So that's why we are getting 252 second. So 252 second is the time required for this kettle to change the temperature of 1 kg of water from 25 to 100 degrees Celsius. Yes, understood this sum? Fine. So we discussed, first of all we discussed about the specific heat capacity, means who is the material with less specific capacity, means best conductor of heat. Okay, it's a good conductor of heat whose specific capacity is less. Okay, because I told you the specific capacity is less means that will get heated faster, that will get cooled faster. Okay, now next we saw how we can mix two liquids or one solid one liquid and what will be the final temperature. And then we saw how to change how to heat a liquid by using an electric device like electric kettle or induction oven. Induction oven also does the same function. Induction oven also converts electric energy to heat energy. Okay, so how much amount of heat it is giving, the same amount of heat we are getting. Okay, so amount of heat taking and amount of heat giving, both should be equal like this. Okay, so understood the sum? Fine, we'll meet in the next video. Thank you.